Well, hello friends. Today we are going to implement rdate. And rdate is a cute little utility that allows you to query the time of a different server. And yeah, so it just shows up like this. And it's less sophisticated than NTP, but very, very simple to implement, I think. So let's see how it works and see if we can make an rdate command for Serenity, because eventually we would like to have NTP as well, obviously, but rdate would be much easier to implement. Protocol, time protocol, right? Yeah, as you can see here, it's a very old protocol, and this RFC. So you connect TCP or UDP on port 37, and then the server will send the time as a 32-bit unsigned integer in binary format and network byte order. Now, that's pretty neat. So the number of seconds since midnight 1900. So it will roll over on 2036. Huh. Well, that's cool. So let's try to implement this. So we'll start by making a rdate binary, and we'll just open that up. And actually, let's see what kind of ports this guy listens to, because I'm going to use this. This is some Swedish university. It's muscle memory, like I used to rdate against this server like a million years ago on my very old ancient Unix boxes back in the day. So they've been open for quite some time. Let's see if it's open on... No, they don't listen for UDP port 37. So let's do TCP port 37. I think that makes sense anyway. So maybe we can try to do this using libcore, TCP socket, and cevent loop. I spent the whole day yesterday refactoring libcore's C object ownership model, and it was time consuming, but now it's finally in a better place. So maybe we'll get to use some of it now. Let's see, return loop.exec. Okay. Socket construct. So this is the new hotness. This is how we create C objects now. Cevent loop is not a C object, so it's okay to put it on the stack, but C objects no longer go on the stack. You have to heap allocate them because they are reference counted. I've wanted to do that forever, and it's finally in place. Anyways. So what kind of arguments does it take? I guess it's this one. It takes nothing, and then we just want to call connect on it. So on connected, we got to set these up first. What are we going to do? I guess we're not really going to do anything. We're just going to... Maybe we can say we can printf that we connected. But really, as I understand it, this server is just going to send us the time. So let's do onReady read. Auto data is socket read all. And then we'll do socket connect. And if it doesn't work, oh, we have to connect somewhere. So let's do ntp lth.sc. Port 37. It's just hard-coded for now. So that would be failed to connect. Something like that. Whatever, it's not the most important thing right now. And then here we can say we got this much data, data at size. And we'll just print the data like that. And see how this works. I think this might not even build. Yeah, because I have to do that. Okay. I guess we should also exit the program here. So let's do that. Hopefully we'll connect and then print out the data size and whatever the data is in between these curly braces. Oh, connected. Now what? Oh shit, I debug printed it. Yeah, so it's here. We got 8 bytes. 8 bytes. Oh. I guess I would have expected to get 4 bytes. 32 unsigned. Time protocol, 8 bytes. That's not what I'm looking for. Well, anyways, let's just try to make sense of what we're getting. So let's bring in the network ordered template because this was supposed to be network ordered data. So where are we failing here? Well, it doesn't matter. Let's see. So connected. We can leave that. Assert data size is network ordered U32 remote time, and actually let's do it this way. Auto remote time is network ordered. We'll cast this. Data. First time. $32. Well, what's in there? Network ordered gives us a T. Oh, right, but it doesn't. Okay. Okay, so I really like network ordered, even though we always know in Serenity that right now, at least because we only support x86, we know that it's always little endian on the host machine, but this allows me to not think about that, and I can just put things or use network ordered to read data that's in network order, and I don't have to worry about the host machine endianness. All right, so this is our timestamp, presumably, and we died or froze. I don't know why we're freezing there. That's a bit weird. So how much is that in years? Wait, what the hell am I trying to do? It's minutes. and hours and days, and yeah, sounds about right. 119 years. Okay, so let's see. Let's do year. Elapsed time. Does this make sense? Wait, what am I trying to do here? Wait, how the hell do we normally do this? I know I've done this before. Okay, let's see here. 32 seconds per year. Let's do it this way. They make it very readable. Wait, hold on. What I really want to do is convert this to a Unix timestamp. Yeah, right. I'm just confusing myself here. So I want to take it and then I guess, is there some way to do dates with a I want to see like the date for a timestamp. Hit me with one of those, please. $20.89. Right. So I just want to subtract from this basically, right? 70 years. Seems pretty straightforward. So what happens if we just do that? Like if we just do this and then we say remote time t adjusted time. Oh, I just got t. Time minus because Unix timestamps start in 1970, if I don't misremember. So let's see, global time. Let's get the date command here. Right. So we can just do that. Because just writing this out is boring. So is that everything that we needed? Wait, why does everything hang? That's so weird. I'm just going to do this here and then we'll see what happens. Because I don't know what's up with that hanging. Like, I wonder if it... Oh, let's just figure out what it is. Okay, so if we die, then it's okay. And then we print out this, which is kind of sort of the time that it is, except not quite, because it's the wrong day. But let's see, what do they say? That it starts midnight January 1st. Let's see, 1970. Somebody, I don't want to look at what somebody else did, but let's see if we can work this out. So I guess we just have the offset wrong, right? But Unix timestamp, did they start like at the end of the first day or something? Assign 32-bit integer. Very silly. UTC. Right, so midnight on January 1st, 1970. Wait a minute. What am I trying to compute here? Okay, let's try that again. But that's not right either. All right, I'm having a brain stupid here, so let's see. Let me work out what the difference is by doing this instead. DC this minus this. Okay, so there's the difference. And how much is that exactly in years? $70, right. Point some number. So let's just take this beautiful magical number here and not worry too much about this right now. And then we can come back when we're feeling smarter someday, because I don't feel smart today. We're just going to do this the not smart way. Say difference between epoch and 1900 is that. Fix me. This is probably not entirely correct. Do something smart instead. Right. You know, some days you just don't feel smart. And that's okay, but you still gotta keep going. So let's see. Then we can just do this difference between epoch and 1900. Okay. Well, what is time t on the system anyway? Some unsigned. Right, so actually we don't really necessarily suffer from the 2038 issue here, but still, it will roll over eventually. Boom. And we're dead. Why did we die? I don't know why we died. We die in loop quit? Is that it? Why would it be a problem to call loop quit? I don't get it. loop is here. It's captured by reference. Why would it be a problem to call anything on it? Rdate. And we're dead. Why are we dead? We have to figure this out. Quit. Great. Let's just see what's going on here, because I am a bit clueless. Echo. Input size that we put it to. What is going on? Okay. So we're printing out a quite reasonable number, which, what's the time in UTC right now? Yep, it's accurate. Okay, that's very cool. So then we know that we have the right magic number here. And let's not worry too much about that. But what the heck is this? So now we die at assertion false here, right? But if we actually call quit, okay, what's my machine even doing? Nothing. Okay. Somebody mentioned that I might benefit from a slightly better machine with more cores and more memory, and starting to think that they might have a point. But I'm going to see how long I can squeeze this for, I think. It's pretty, I don't know, I feel some resistance towards buying a new machine right now. But sooner or later. Okay, well, this is clearly weird. Okay, wait. Can we get to it some other way? Wait, virtual. Does anyone inherit from this even? G event loop. Does anybody use G event loop? Yes, they do. Okay. Well, that's nice. Although, it doesn't really seem to have any virtuals. Does it even do anything? Not really. Okay, so we can get rid of this, and okay, well, that's a whole other thing. Should probably get rid of G event loop since. Should I do that now? Yeah, what the hell. Wait, it inherits some C event loops. So basically when you instantiate it, then you're just instantiating the C event loop and then making sure that this thing exists. Right. So let's just look where we do make G event loop. here, when you're creating a G dialog, then you're far into execution already. You already have an event loop. But here, this is where we need to make sure that we connect to the Windows server. So we can do this. Then the event loop will be a C event loop. It's actually kind of neat, because I would like to maybe someday be able to have like a libcore application object, not just a G application. But there's a lot of GUI stuff in G applications still. Anyways, this brings us one step closer to having a libcore application object, which might be interesting. Okay, so let's do that, and then G event loop basically disappears. It's kind of funny, the G event loop disappears, and then another class has taken his place in G event loop.h. The Windows Server connection. Which is a bit funny, because then we got all of these files including it. So who calls stuff on it? Let's just get rid of this and this. Okay. And these should just be C event loop. Well, this actually, I'm quite happy about this sudden sidetrack, because that means that we can devirtualize this, which makes it a bit less complicated. Because event loops are usually getting more complicated over time, but this actually simplifies it a little bit. So let's rebuild with those changes. And, you know, we'll eventually get back to rdate. But okay, so what the heck happened? Oh shit! Guess we still had these smart pointers. So you can just have regular CLO, because gdialog has a nested event loop. That's what's going on here, which is actually really neat, because it means that you can create a gdialog and it becomes modal, and it's modal because it runs in its own event loop. So whatever was going on in the outer event loop, we don't care about that. Like, we run our own event loop, and then when you press OK or cancel or something in the dialog, then you exit the nested loop and go out to the outer one. It's quite nice. I like GUI programming. It's very, very chill. I guess based on what you see me doing on this channel, it's probably the thing that I like the most at the moment. Although, I like other programming too. Thankfully, this project has a little bit of everything. So I don't know what's going on here. Let's just do it this way instead. Like that. And we'll just grab a C. Okay. And I see that we are missing file.h. No, stdio, not file.h, and stdlib. Let's just include those. Make syntax highlighter happy while we're here. It's a little bit silly to do that, but I'm gonna allow myself. It's like a treat. Exits. Yeah, so you need stdlib.h for exit, otherwise the syntax highlighter gets a bit upset. These, I'm not gonna care about these. Okay. Okay. Let's see. Just make sure that everything still works. No, it doesn't. See event register notifier. Windows Server connection. Oh shit. Right, yeah. So in the Windows Server connection constructor, we need to already have an event loop. So actually it's good that we reorder this, because previously we were instantiating the Windows Server connection inside the event loop constructor, which meant that the event loop was not technically fully ready, even though it probably worked out luckily that way. Okay, well, so everything appears to be spick and span, but let's see about it, rdate. Okay. Connected. Wait, so that first time we didn't get connected. Just got data? That's so freaking weird. What the hell was that? I don't know what the hell to make of this problem. So this is the first run. Connection in progress. Connecting to the connection in progress. Okay, now we get here. And the second time we got connected. And the first time, okay, well, let's commit those changes first of all. So this is all just that stuff. Right. Lip core. GUI remove G event loop into C event loop. Was just a dummy subclass of C event loop anyway. The only thing it actually did was make sure AG window connection was instantiated. Right now, I'll take care of the ng application instead. That loop is now a loop. Now, non-virtual and a little less confusing. Cool. But what the frick? So yeah, so we have two issues here. Like the first one is obviously that we just hang, which is really, really weird. And the second one is that we didn't get the connected callback. But instead, this is when we didn't get it. So this protocol disconnected, what does that mean? We got to receive from, so we're calling receive from. Which means that we called receive from on the socket. We had no data to give you. So we just returned 0, but we had already received some data here anyway. But why didn't we get the connected callback? That's what I want to know. Connected. Let's see. So I'm ready to read. Wait, how does the connected work? So we get connected when we're able to write to the socket. That's a little bit weird. I mean, I guess we could get the... There's nothing saying that we wouldn't get ready to read from socket before this. So does this even make sense? Like, why do we have a ready to write notifier set up? Why is it built this way? Andreas, why did you build it this way? I don't remember. Let's see. I guess I must have figured that once you've connected, then you're able to send something, and that's what makes the connection like ready. But if you're able to read, that's just as connected, I think. I mean, ready to read, you could also be like EOF. We don't know how much we can read here. So we don't know if it's connected or not. I guess we could find out. We could do like, where do you set connected? M connected is true, we set that here. So what if we were to, here we would check how much we can read, and if we can read a non-zero amount, well, if it's not connected already, then we'll check if we can read from it. I guess we'll have to use select, or wait, can read from file descriptor. Can I call this? Because I have this exact functionality here that I want, but I'm not able to call this. But what if it were protected? Then I could call it. If can read from file descriptor. Wait, what does that check? If it's readable. But we still don't know how much we can read, so it might be an EOF. But should we consider EOF state to be connected? I feel like we shouldn't. Maybe this is why I decided that writable means that it's connected. Oh, this is so weird. So I'm not really sure what the fix is. I guess one way that we could dodge this issue for the moment is that we could give write notifiers priority over read notifiers. So let's see. Let's undo this change, by the way. Libraries libcore. Notifiers. So this is, let's see, where do we actually check what happened to them? Here, we're checking them. Let's do this. Notifiers. Right. Actually, we can do it this way even. We can do two passives. And then if we have some ready to write ones, then we'll do those first. This is a very strange solution, but let's try it out. So let's see. Note, check writable status first, because that's how sockets determine that they're connected to something. Maybe there's a much better way. There's a better way. Yeah, I would like to know if there's a better way. Do you know a better way to tell that a socket is connected to something? And now we got connected first, of course, and then it hangs, which is frustrating. Why does it hang? What is the machine doing? I am so confused. Okay, let's just go and do what I usually do in this situation and turn on scheduler debugging, and then we'll find out what the frick the machine is doing when this happens. It's going to be very spammy for some time, but okay, this is just too spammy. Let's turn off some stuff here that we don't need on startup. Don't need you, don't need you, don't need you. Can live without the taskbar. And we'll do that one. So only the context switches and runnable debugging. Let's figure out what the machine is doing. Okay. It's actually surprisingly responsive for like printing out literally every single context switch that we're doing. Okay, boom. And come on, put us in the weird state. I guess it might take a moment to get us in the weird state. Failed to connect. Well, that's not what I want to hear. Wow, my fan is just going crazy. Maybe I can move it a bit further away from the microphone. Okay, this is not really working the way I'd hoped. How the heck are we gonna get it to connect in this state? I don't even know what the issue is. Like, is it too much spam and we're too slow? Oh, there we go. But now you worked. All right, well, come on. Oh, it's one of those, huh? You don't want to do it while I'm looking at you? Damn it. All right. Let's turn off this debugging. Try again. Only the context switches, not who is runnable. Oh, and we're dead, but in some different way. See from... This is not the problem we were having, though. What the hell is this? I don't recognize this problem, but let's just paste that here just for so we don't forget about it. Okay, please get into the weird state. You're just not going to do it because I'm... Okay, here's that weird state again. Could this be related though? Maybe, I don't know. So local socket receive from is failing. Why? Local socket receive from. Where are we? Here. For server. I guess we are in the. So we can see here that it's on a context switch to the lookup server, which is the DNS client of Serenity. So we switch to him, and then he says, hey, I tried to look in my for server buffer, which is me, and it's not empty. Assertion failed that it's not empty. Wait. Assertion failed that it's not empty. So it is empty. Right. And why am I here? If it's blocking. If it's non-blocking. Wait, how the hell does this even work? Who calls this? Receive from. But where would we block? I don't see where the blocking is happening. IPv4 socket blocks here. So local socket, if you have a blocking local socket, which I guess we do. If it's blocking. Maybe it's not blocking, who knows? Why are we here? We're calling receive from. Okay, well this is clearly not right. We should definitely be blocking here if we need to. Let's see if the description is blocking, then we're here. And then we'll say we'll block the current thread with the receive blocker on that description, and then we'll see thread blocker. Wait, how do we? I forget how this works. What's the thing that we get from calling block? Block result. Interrupted by signal, right. Okay, I think that's what we want to do. So if we're not blocking and it's empty, then we'll just return. Otherwise, if it is blocking, then we will block. We should only block if it's empty. So I guess like this. Oh shit. Does that make sense? And probably we should do the same thing down here in the client variant of the same thing. So that would just be for client, and then we block on the same thing. For client is empty. Oh, wait, this is at the wrong level. There we go. Yeah, this makes more sense. Yeah, we're still failing. Why are we failing now? 247. I guess we'll say if m4 server is empty. I'm just gonna help myself a little bit, do some debug info. Because I am just thoroughly confused here. Okay, there we go. Thank you. Blocking is true. So we're blocking, but so we didn't take this branch. We took this branch. For server, it should be empty. Let's store this away somewhere. Did block false, because now I'm getting suspicious here. Wait, who's messing with us? Blocking true, did block true. Oh, wait. Maybe it's okay. Maybe it just means that it's an EOF condition. Fuck, I forget how this works. So we're trying to receive, but it's disconnected. Maybe it should be okay to read nothing. Because then we'll just read. Let's see. If we have nothing to give you, we'll give you a 0. I think maybe that makes sense. So what if we just let go of that? We unblock. Well, why did we unblock this one though? Can read will be called. So let's see. Oh, maybe the condition is that we don't have an attached peer anymore. Right. So if we lost our peer, then shit. If we lost our peer, let's see if has attached peer. What does the receive blocker do, by the way? Just calls can read. Okay. So if we don't have an attached peer, we're accepted. So we want to, right. Description, then we want to return 0. Otherwise, we should have something from the server. Okay, yeah, because if our peer has disappeared, then has attached peer, and we don't have anything. Because if there's still something in the buffer, then we should give you that first. But after that, if we don't have an attached peer and there's nothing left to read for you. Okay. And we'll do the same thing down here. Wow, this code is identical except for which buffer it uses. This is stupid. This should be factored. Anyway, we are just going all over the place today. Okay, so now we died. Broken pipe. We failed to connect. That's okay. Failed to connect where though? I guess it doesn't even matter really. So sometimes when we fail to connect, now we don't like completely lose our head about it. Can I get one of those failures again? Okay, well, this seems like progress. So let's see what we've changed. Let's check out scheduler. Wonder if that weird Heisenberg will come back now. Sometimes it doesn't say connected. Why doesn't it say connected? And there we died in that weird way again. Why? Okay. Well, we're just gonna keep fixing bugs and see how far we can get. So let's commit this. So this change is about making sure that we block. I wonder if we have a bug about this. So this is about making sure that we block in wait, hold on, am I doing this right? If our server is empty, so it is blocking. Maybe we should call can read directly in this case. Yeah, that would just be easier actually. So else if not can read. For this file description, what does send to look like? Oh, send to is a bit easier because then if you don't have a period, you just say no, can't send. Yeah, that makes sense. So this is, let's see. Oh. If you try to call it receive from in a listener socket, now I'll just get really confused, I guess. And just assert. Well, that's something entirely different. But I don't like that this code is so confusing. What is this thing? It's a double buffer? Yeah, okay, so let's just simplify this a little bit here so that it's understandable. Buffer for me. Buffer for description, and then we can pick it up that way. Okay, so let's see. Let's do exactly this. Okay. For server. Connected, then for me is for client. Otherwise, we'll just assert not reached. And then here, description. If can read description. No, well now can read will be true. No attached peer and it's empty. Yeah, right. So this is still good. Okay, that's significantly simpler. Still kind of confusing, but less so. Let's just check that it actually works. Oh, I forgot to add this to the class. Just checking that the windowing protocol still works and everything. Yeah, we're good. Actually, let's... Oh, what's that about? Connection refused. Why can't I connect? Oh, audio server is not running, of course. I turned it off. Yeah, we're good. Okay. And there's that weird death again. What the frick? Okay, let's see if we can... If we can still react in the keyboard when this happens. So let's just make it happen and then see if we can still print from the keyboard interrupt handler. Yes, we can. Okay, we're dead, but we can still print from there. So, say that when you press the logo button, we will scheduler go bananas. Or hold on, let's make that an extern. Do this, and then scheduler, we'll just do one to go bananas. Bananas. False, and let's see, log every context switch. Let's just say if g bananas. Okay, this is going to be very not fancy right now. We are just going to find out what's going on. Okay, so when we press the super key, then things will go bananas. Yep, that works. Okay. Okay, what the hell is happening? We are switching tasks. Let's see. Everyone is runnable and everyone is at this address in the kernel. is the switch now? Everyone's in switch now. Why? What the heck is everyone doing? Scheduler debug. Let's turn on all the scheduler debug stuff as well. This is some truly sophisticated techniques going on here. But I rather like this magic key that like just causes the scheduler to just start spewing. It's actually extremely cool. I should probably commit that somehow, but I need to clean it up and figure out a nice way to do it. But some interesting feature. Okay, so now it's hung. Can't do anything. And what are you doing? Windows Server is donating to rdate. Okay, so the donating thing is that whenever a process is holding a lock, then if some other process wakes up and he wants to use that same lock, but it's already taken, then he will donate his remaining ticks, like scheduler ticks, to the process that's holding the lock. And what we can see here is that everyone is donating their ticks to rdate. syncd is donating to rdate. Windows Server is donating to another one of its threads, and then the other thread is donating to rdate. So everyone is donating to rdate. Because why? Because he is holding the file system lock. Why is he holding the file system lock? So yeah, so it says here that they're donating all of their scheduler time to rdate because of the file system lock. Why would rdate have the file system lock? Is it because we're trying to exit the event loop, and then what happens when we exit? Do we have any interesting members that will be torn down? I guess the RPC server will be torn down. So is it that we're trying to kill the RPC server? What happens when this gets torn down? Okay, so I have a different approach that we can use to learn some more. We can log all the syscalls that happen. So let's see. If current process name is rdate, debug. Rdate syscall. Let's say syscall to string function whatever's in EAX. Okay. Let's see what kind of syscall it's making before we get all dead. I'm going to need to make sure that we get this in a file so we don't lose it. Okay, so here we died. The last thing that happens is that we do a debug put string. That's a bit weird. Why would it be holding the lock? I don't get it. I'm so confused. Does this happen with other programs too? What if I just run the text editor and then try to exit? Doesn't seem to happen here. Okay, well, this clearly needs some separate investigation. So let's see about committing this local socket improvement, because I think that one was very nice. Local socket, cp, local socket, simplify, receive from, duplicating client, sharing code between client and server. Edit a buffer for file description helper so that the client and server code paths can use the same code path. Let's see. Teach receive from how to block it and simplify it. If we can't already read when we enter record from on a local, we'll now block the current thread until we can. Okay, that's a pretty good change, actually. I like that one. Very good. Okay. Then what the heck else did we have? The writable status thing. I feel like that didn't have the effect I was hoping for. See event loop. We check writable status first, blah, blah, blah. That's really weird. Maybe a better way is to not set up a ready read notifier until we have determined that it's writable. Let's try doing it that way. So let's see, if I'm connected, then we'll do this. Let's see. And then did update file descriptor. Who the hell calls that? csocket, CIO device. Okay, so then let's see if I'm connected. Share read notifier. Let's do this. Okay. Assert connected. Let's see. And then when we set connected, here we'll do sure we define. Okay. If we don't have a read notifier, then what the frick do we do? I guess, well, no, we don't have to worry about that case here, actually. Well, we could assert that there is no read notifier. Wait, what? Why are we here? I don't even know how we would be in this state. What? Yeah, wait, no, I'm just confusing my future self. We're not going to be in this state, but we'll add an assertion. We should, I don't think it would be right if we updated the FD while connected, while not connected, but while having a notifier. I don't know why I spent so much time on that weird state. I guess because I don't understand how we would end up there. Ensure read notifier. Right, so now we're not going to create the read notifier until after we have become connected. So let's see how that works out. And of course, I still have absolutely no clue why rdate is holding the file system lock. But I'm suspecting that that's some completely goofy, unrelated problem to anything that I've looked at so far. But maybe not, who knows? And now we don't get a terminal, why not? See on connected. Do we depend on that? Yes, we do. We depend on that in. Wait. Oh, I'm ready to read. I'm ready to read is used in the IPC stuff. So now we're not getting on ready to read. I guess because we're not getting on ready to write. Well, why is that? In order to get that notification, we would have to have a can write return true on the local socket. Which would, let's see, so this is us on the GUI client side. If we don't have an attached peer, it's an EOF condition, so then we can write, fail. Otherwise, if we haven't already sent 16K, then we can also write. Wonder if we're in that situation, but that would be kind of weird because we haven't sent anything yet. What Why would we not be able to write? I don't get it. Notifier, comment, okay. So, what did terminal say? Terminal says connected, okay. And then we call ensure read notifier and then invoke onConnected. And then what about ensure read notifier? What happens? Wait, so we make one, but then why doesn't it get invoked? I am slightly confused about everything right now. Completely lost track of what the heck I was trying to do here. So we have all these changes. None of this is really useful. I mean, it's useful, but it's debugging code. Let's see, ensure read notifier. Well, oh, here's this one I saved. I'm just gonna make doubly sure here that I'm actually instantiating it. File descriptor. I mean, we have a sort of working rdate program. It's just it's not behaving right. Ensure read notifier on FD6. Okay. And then he starts up a shell and everything. Wait, so what's going on with this? Maybe the terminal side is fine. Maybe the Windows server is who's confused. What does Windows server say? Core IPC server. Let's look at this. What does it do? Let's see, local server. We accept a local socket. Oh, but when we accept a local socket, it is already connected, and then we have to ensure that it has a ready to read notifier. So, let's see, how does that work out? I think the issue is probably that mConnected needs to be set when we are instantiating from a file descriptor, because we only do this when we are accepting a connection. Connected is true. Does that make sense? Where's mConnected? It's protected here. Yeah, right. And then actually this should probably be the same CTCP socket. Note, this constructor used by CTCP server except the socket is already connected. And we'll put the same kind of comment here just to hammer the point home. And that means that when we call it setFD, called it an updateFD, And then mConnected will be true, and we will ensure that there is a read notifier on the accepted connections, which should make the Windows server actually react now and give us a terminal. Nice, okay. And do you want to go into the bad state, please? Seems like it doesn't right now. Okay, well, I don't know what I did to make it stop at the moment, but I'm sure that it will come back sooner or later, unless I actually fixed something without realizing it. If you spotted what I did, then please let me know. But, you know, it's okay, because when you sit down like this and you're just working kind of aimlessly on all kinds of problems, then you end up with a lot of nice bug fixes, and that's really awesome. Oh, we're dead. Okay. So now we're in the weird state, and rdate has the FS lock, so he's holding the file system lock once again. And everyone is waiting for it. Oh no, well, not everyone, but Windows Server wants it. And the reason Windows Server wants the file system lock is because... Wait, why does he want the file system lock? He just wants to look at proc all, I think. He wants to look at with the CPU monitor, which uses process statistics reader. Oh, but it opens it by doing like open proc all, so it has to search on /, which means that he needs the FS lock for the root file system. So this could be better. I mean, this problem could have been avoided in some ways, but we should eventually figure out why rdate is holding the file system lock in the first place. Can we maybe get a backtrace on the lock holder, I wonder? Well, let's see. Let's do the socket fixes first. Libraries, libcore. So these are all good changes suddenly. Libcore. Oh. Libcore. Don't create a read notifier. Say csocket. Don't create the read notifier until after we've connected. This allows us to, this makes it so that on connected is always comes out first. Always gets called first. Since accepted sockets are connected at inception, at construction, before construction, they have to manually set csocket connected true. Yeah, I think that's pretty good. We don't really have a clean disconnection story yet, but we'll get there too someday. Anyways, accumulating some nice changes here. So let's see if we can get a stack for that lock holding thread. We will go to donate, where we donate the time from one thread to another. So when they donate, let's find out why. If G bananas, very fancy, and then who's holding it? The beneficiary. Beneficiary is the thread that is currently holding the lock. So can we get the back trace? Ooh, how do I do this? How do I get a process inspection handle? Beneficiary process. I think I need a handle to make sure that because this blocks the other process so that he doesn't try to run while we are inspecting him. It's not going to run anyway because we've disabled interrupts, but I think the API here requires that we have a handle. So let's see. Debug backtrace. Will it work? I have no freaking clue. I don't know if it's safe to call backtrace like that from the scheduler, but we'll find out. So we can just do this. Oh shit, there's no way to turn it off. So let's just get to the bad state. There we go, and we can't do that. Process being inspected. Why can't I do that? Blah, blah, blah. Okay, let's try something else. Let's look at context switch. So let's see. No, let's look at timer tick, actually. When we get a timer tick in... No, where the hell do I want to be? In switch now, maybe? Okay, let's go here. If, oh well, where the hell are you, rdate? Okay, fine, let's do timer tick. When we get a timer tick, if current process name is rdate, and we are in bananas mode, current backtrace impl. What happens if I just do that? Wouldn't it be nice if that just worked? Please just work. Maybe we're never ticking in rdate, actually. Damn it. Alright. So what are we doing? Are we yielding in rdate? Maybe we're yielding in rdate. We can certainly do that here too. Okay, ooh, we got some stacks. What the heck is going on? So, page in from inode. What? Page in from inode calls backtrace impl. Wait, what? Oh, this is so weird. So we're trying to page in some part of the rdate executable, and we're holding the fs lock while waiting for the hard drive. This is probably not necessary, by the way. We're locking like way too aggressively in Serenity. We can improve performance and responsiveness so much by locking less. I've just been using like an extremely hardcore locking approach just to avoid data races, but instead I have deadlocks, you know, so it's not, this is the first deadlock though in a long time that I've looked at. So yeah, so we're hitting a page fault and we have to page it in from an inode. So we're paging in what I assume is the rdate executable. And then while we're waiting for the IRQ from the disk drive, then we donate our time to someone. And then we hit the timer tick, but then we can actually probably get rid of the timer tick thing. Maybe we can just skip that one and only look at yield. So maybe, but it is interesting that we are, oh, it happened right away this time. Okay, so that's, I guess this one is good. For IRQ, and then we do a backtrace, and then we try to backtrace, and that will also try to read page in a different part of the executable. That's quite weird. Well, I don't know how to solve this right in this very moment, and I don't want to start debugging it, so because it's getting very late, so I think we're just gonna end it here for today. But we have seen some interesting fixes, and we now have something new to worry about that I don't fully understand yet, but yeah. So yeah, I guess this is turned into what I was talking about the other day when I rage quit on my traceroute thing. I don't know if you saw my commute talk about rage quitting, but today I didn't rage quit, even though I ran into all kinds of problems. And yeah, I hope you saw something interesting here, because it's a little bit different. I didn't finish everything that I set out to do, but at least we got some cool stuff, some nice fixes. Especially the local socket one I really liked, so I'm just going to push those. And I think we're going to end it here for today. So if you made it this far, I hope you saw something interesting. And have a great day. Let me know what you thought about this type of content. Still okay? Yeah, see you next time. Bye.